Hey guys, how you doing tonight? It is the 30th of April. Thank God this month is over. It's been a long month, hasn't it? Okay, so these are the answers to quiz 11 that I gave you guys last week, and we have yet to go over them. So let's go ahead and review them real quick. Question number 1 had to do with venting, and what's the minimum grade of a vent? Level. Code section 905.1 of the 2018 Uniform Plumbing Code. The code section might be a little bit different in the 2015, but we're going off the 2018. Number 2, let's see, the answer is 15 feet. So I believe the question was combination waste and vent. How long can it be before a separate vent is required off of the branch? And that is code section 910.3. Number 3, the answer is pressure regulating valve with a strainer, and that's code section 608.2. The question was, if you have an 1.25 inch service line going into the building at 85 pounds per square inch, what is required? So that's your requirement. Once you get to 1.5 inches, you don't need the strainer any longer. Number 4, code sections down here, 1212.9. And this is, where do I not need a sediment trap for a gas appliance? Any illuminating appliance, any range, surprisingly, I bet some of you guys thought that you needed to put a drip leg or a sediment trap for a gas range or stove. You don't. You don't need one for a dryer. You don't need any for a decorative appliance in a vented fireplace, gas fireplace, or outdoor grill. Things like water heaters, you need to have a drip leg, okay, or sediment trap. Number 5, code section 609.32. Where do I have to have brazed joints underground? And that's the code section that is in reference to it right there. So there's your answer. There are your answers. We'll use proper English here for quiz 11. I'm erasing this, so be sure to pause so you don't mess up. Okay, so we're also going to go over this, which you all should have a copy of. We have, hang on a second, one of my blackout curtains is falling. Hang on one sec. Let's see if this works. We'll see how that comes out in the editing, huh? Okay, so where was I? This. So the first is S or WBG, that is sanitary or sewer. W for water. BG is below grade. Then you have the next one, which is S or WAG, which is obviously sewer or sanitary, water above grade. The next one with the dots is V, that is vent. CW, cold water, okay. HW, hot water. HWC or HWR. HWC is hot water circulatory or circulation, and HWR is hot water return. Mostly what you'll see is hot water return. Plus, in some of these other sheets, you may see it written as DHW, DCW, domestic hot water, domestic cold water, because also you have industrial cold water and industrial hot water. Can't drink this, totally drink that, right? So those are, I believe that you get those further in the handouts. Then you have SD. SD would be for storm drain. G, come on, it's gas. You could also have MPG, which is medium pressure gas, HPG, high pressure gas, LPG, low pressure, or liquid propane. Okay. SOV, shut off valve. This symbol for a shut off valve, that one that you see there, that is so common. That is one of the most common symbols that we will see on our sets of plans. Okay, so if you have one that's like this, you know, and differentiates between this and that means there's two different sets of types or two different types of valves. This one they might say is a gate valve, and this one they may call a ball valve because it's got the little ball in the middle. It depends. These symbols that I gave you, they're generic, and that's why I gave you so many different sheets of so many different symbols, because some symbols are varying off of whoever designs the sets of plans that you look at, and these are all the abbreviations and symbols that you see. So next one down is COTG, which is a clean out to grade. Looks just like FCO, which is a floor clean out. POC, point of connection. CD, not compact disc, okay, but a condensate drain. You have to excuse my dog is barking. So RD, roof drain. OD, overflow drain. The symbols look identical because the drains themselves are identical, and they're usually right next to each other within 2 feet. FD, floor drain. FS, floor sink. WH, water heater. A symbol for water heater. WH circled, water heater. WM, water meter. IE, I've talked about this before in class, guys, so hopefully some of you actually got this. IE is invert elevation, okay? So hopefully you get that, invert elevation. And the invert elevation is from the ground, all right, from grade to the bottom of your pipe or flow line. That is your invert elevation. FFE, finished floor elevation. WCO, wall clean out. And HB, hose bib. That is the first page. Second page. We'll cover just a couple of these. The ones that are actually very important to know. Pressure and temperature relief valve. Where is that located and what do we do with it? And a lot of people don't call them necessarily pressure and temperature relief valves, but a temperature and pressure relief valve, or a TMP valve. And those are on the discharge side, or actually connected to, rather, the water heaters. And those are for if the pressure goes up above how much, guys? Come on. What's the pressure? Over what? I'm going to leave that one to you to answer. And I'm going to leave the temperature for you to answer too. So for a temperature and pressure relief valve, you need pressure. What is the pressure? And then what's the temperature? I'm not going to give you the answers. You're going to have to email that to me. And do that. Email the answer to this. That's your quiz for tonight. Answer this to me as your attendance, your sign-in. So when you reply, tell me what this is. And if you reply and don't look at this, I know you didn't look at the video. Haha. So that's temperature and pressure relief valve. Let's see, pressure reducing valve, or PRV. It looks just like a regular shutoff valve, but it has that little flag. And there's also another symbol where it does that instead of a flag, like a little pointy flag, like the one that's on there. They'll do it with a P. So then you have the gate valve, globe valve, check valve, check valve. So these are all symbols, and you can see that every single one of these on this list is written differently because this was taken off of a set of plans for their set of drawings and what they used. The check valve, got the little deal right there. The flow is that way. Okay, so this is where the little on the inside of the check valve, the little paddle that's inside there, why does the name escape me right now? Flap. The flap that's inside is in here, so when the water comes through, it hits this ball and opens and checks out. And when it reverses flow and goes back this way, the flap will close and it stops the flow from going backwards. So that is your check valve. A lot of these symbols are going to be on your test, guys, and that test is coming next week, by the way. So I know there's not much to test on, and I haven't been able to give you guys any sets of drawings, but it is what it is. And then they have the symbol for the ball valve, which is one that's kind of rare. I don't see that one very often. Butterfly valve, which is very similar to the ball valve, except for the flange goes all the way down and lines all the way through. Then you have the gas cock, which is essentially a gas shutoff valve. Then it shows the symbol for a T. Then it shows the symbol for the valve on the rise or the drop. So on the rise, you'll see that it's the solid circle signifying that it's a rise going up, right? And then it shows just half of that ball valve sticking out. So there's your valve on the rise. The valve on the drop, you'll see how it goes in there like that. That signifies it's a drop. It's going down. And there's your valve right there. It's hard to... So, yeah. Okay. CL is a capped line. You've seen me draw that several times for caps. And then you have the symbol for down or drop. And there's two things there, okay? And this is interesting because I've shown you this one before. Okay? And then they have this one. I've never been able to do that one very well. Obviously, this is for a T instead of a 90. So this is a 90 and this is a T. And hopefully you were able to discern that. And since the T is looking down, the pipe going across, you don't see the T, okay, or the branch going down. So that's that. Then the one below it, you have up or rise, which is completely opposite. Right? So this is a 90 up, and this is a line that's coming across and a T going up. You can see right down the pipe. That's why it's a solid circle going all the way up. Then you have direction of flow. Then you have the slope and the direction of fall. So in other words, what they did was they just did an extension line there, right? So all they did was they have this is your water line, and they're all, oh, hey, we want to put slope or what kind of fall you've got going on there. So we're going to go ahead and do this. And we're going to put 2%, right? So it has 2% fall. And by the way, we're also going to put in a direction arrow to signify which direction you're headed. So there's your direction of flow, and there's your slope. Then you have the reducer. If you go down further down, we'll get more into the reducer. That's one way of putting a reducer. Then you have a two-way control valve and a three-way control valve. These are for heating hot water systems. I've mentioned this before. I think I may even have talked about it in one of our discussions, where you have a heating hot water system and it's going through a series of coils, right? So you have hot water, and this is your supply going this way, and it comes out that way. What you have is a two-way control valve. So here's your two-way control valve, right? That two-way control valve, a lot of times they'll run a wiring off that too. And I think there might be one in there that shows it like this. And what it is it's just two ways, either stop or go. That's two ways, right? And it's just one coil. The three-way control valve looks like a little angel, you know? That is so that it can come in and tie into the other side of the coil. This is the one that's at the very end of the line, because you want that hot water to continue flowing all the way out to these heating hot water coils. And you want that hot water to be continuous, so the end of the line, it doesn't deadhead and stop when it doesn't call for heat. It goes through and goes back to the boiler to reheat and reconstitute. That way you have a consistent and constant flow of hot water throughout the entire system. Without it, if this doesn't call for heat, the end of the line, there's no more flow. So it locks and it becomes negative pressure on this, and you can't have negative pressure. When you have negative pressure on the return line, you don't have flow. So you have to have, at the end of the line, that flow to continue the cycle. Then you have another symbol for hose bib. Then you have the concentric and the eccentric reducer. Two different types of reducers. Concentric means everything goes in at the same time, to a certain point. So you go from 2 inch to 1 inch, both sides reducing at the same time. The eccentric reducer, and it sucks because they have this done flipped backwards. The eccentric reducer maintains flow line for drainage, for draining. Because if you're running like this and then you reduce like that, and you have to drain the entire system, let's say it's like a clean type of system or a product system or something like that, where you need complete drainage and everything, nothing in the line, you're going to have a collection right here, right? That's why a concentric reducer is not always the one to use. You can use an eccentric one where the flow drains out and is completely gone. So that's the difference between concentric and eccentric, and the reasons why you would use an eccentric reducer as opposed to a concentric, which most reducers are concentric reducers. I'm going to try and make this as quick and painless as possible for you guys, because you got some studying to do. Next week's you're going to have a test. Another symbol for POC, point of connection. The pipe risers, a lot of this is repeats. Get to the CHWS, the CHW return. That's chilled water supply, chilled water return. Hot water, heating hot water supply, heating hot water return. The good thing about this list is, and we're on this one here, guys, apologize. The good one about this is it gives you the symbol and it gives you the description. So the test well, TW, test well, or Pete's plug. For years, I was like, "Guy, who's this guy Pete?" Because it's called the Pete's plug, right? It's not this guy Pete. It's PT for pressure test. It's a plug and port where you put your gauge on to test flow and pressure. It's a pressure test port or pressure test plug. PT plug, Pete's plug. I thought it was some guy named Pete. Nobody would ever give me the answer. I had to figure that one out for myself. The strainer and the union. The strainer, you see how it looks like that? What's the direction of flow? Okay, this is a Y strainer, because see how it kind of looks like a Y. As the water traverses this way, it has to go through the strainer before it continues on. So it'll collect any debris inside that strainer, and it's a little mesh basket. Typically, we can unscrew this and remove the wire mesh, clean it, put it back together, be done with it. So that's the direction of flow, not this way. It's not going to work if it goes this way. It just won't. Air vent valve. Then we're going to get to this symbol and abbreviation description page. See if there's anything discernible on here. The only thing I can say is if you take a look at the symbols, you'll see that the line variances will be separate, like cold water, hot water. You have this for cold water, and then you have this for hot water. So they'll mess with the lines a little bit and put in some dots and some dashes depending on how many different systems you have. The largest building I did with the largest amount of systems, I had 22 systems in one building. And so there were several different types of variances, but it got to the point where I was like, you know what? Nobody's looking at the lines to figure it out anymore. They're looking at the abbreviations, because every single one of these lines is going to have written on it the abbreviation. So you just look at the abbreviations. There's that medium pressure gas that I told you about, the MG. A lot of times, though, they will actually say MPG, medium pressure gas. We as plumbers, we try to make it as easy as possible for ourselves. So that which is in there, okay, so you got a line that's like this, E for existing, so that's the existing line. Then you have another one, EQ. EQ is equal, all right, so equal distance on either side. EQ means equidistant, okay, existing, equidistant. Typical. So they'll show one thing and say typical. In other words, unless you're otherwise notified, this is the typical way you're going to be doing it. This is the typical size, the typical, measurement, everything. Typical installation. RFI, request for information. It's not in here. I just thought I'd bring that up. There's a couple other things I just want to talk about. We're going to more of the same symbols and stuff, guys. This is actually a pretty good one. This is a good page. Okay, it lists, and it's a lot cleaner. It lists the symbols and the abbreviations and everything, and this is a lot cleaner than the other ones. Okay. Take a look at this page, study this page, because some of those symbols I will be asking for you to draw on the exam. Okay. And you're going to do it. This is the one I wanted right here. This page. Okay. Got it? This is called a section cut, or a wall section, I think they have it referred to. So you have this circle, and then you have this, right? And I believe they have it written as a 2 and an A4. So this is what this means. As you're looking down on the plans, picture this is your head, and that's the top of your hard hat. The top of your hard hat has a 2 and an A4 written on it, and you're looking this way. So this is your line of sight, right? from this vantage point right here, looking this way, you're going to see a detail number 2, and you're going to go to this page, A4, A being architectural. So you go to page A4 and look at detail number 2, and it's going to give you an interior elevation side look, not overhead like a regular plan view, but you're going to see it from the side. That's what this is. It's a section cut. It's going to cut this section out, and it's going to show it to you. Okay. Another way of doing that is right below it, without the arrow, you'll have a circle just like this one is, and this is a 3, and they have what, L5 written there. This section cuts an entire section, okay, and it's usually hooked up to a dotted line area. So this whole area gets dotted, and it goes to this. This completely cuts this section out and blows it up and makes it bigger. And that's going to be detail number 3, page L5. What do you think L stands for? It's not typical in every set of drawings, but the L is landscape. So this is an exterior cut of a certain section that they want you to see a bigger picture of. But it is very common to do this on plans because, especially for us, bathrooms. So you have this huge floor plan. Here's your bathroom right here, right? And that's only a little portion. How are you supposed to see the detailed measurements of all the different restroom appliances or fixtures, excuse me? What's the measurement for the water closet? What's the measurement for the lav? You can't do that. So what they'll do is they'll do a complete section cut and send it over to a detailed page, and that's going to be in the architecturals. So we as plumbers have to get into the architecturals to see where we have to put our pipes, okay? And you would think it would be different. You think it'd be in the plumbing. Plumbing's got no dimensions, and it just shows you where everything goes. All the dimensions are in the architecturals. Oh, I like this one because I use it a lot. Where the C and the L converge, that is the center line. At this point right there, that is the exact center line of, let's say, we have to be centered of a cabinet for a sink. We have to cut in a sink. It has to be in the center of that cabinet. We go off the center line, okay? Then it shows you on this page, the one that we're still on, right? It shows you the different types of lines that you will see on the plans. The main object line, which is a heavy, dark, solid line. The hidden or the invisible. In other words, it's behind something solid. And so you'll have something solid, and then it'll be dot, 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 and then solid again. That's because it's behind something, okay? And then you have the center line. Then you have dimension lines. Remember, we talked about that in class. We did. The dimension lines, the extension lines, then the center line symbol, and then on every set of drawings, plan north. They always point north, so you know exactly how to put the building in. If you go to this page, there's really one on here that's related to those other lines that I told you about. And it's a little lower than halfway down the line. And it's called a break line. And that break line, and I've done it in classes with some of those drawings, I've done stuff like that. So let's say we have something on detail that we want to take a look at, and we only want to see this part and this part where they both tie in to the building or to the structure, and you don't necessarily need to see anything in between. Let's say like this is 280 feet apart. I'm not going to draw a detail for 280 feet. You're not going to get a detail that way. I am, however, going to do this side and this side, and I'll just break it because I don't care about anything else in between. And that's what the break lines are usually for. Then you have the extension line part where it refers to note. It says refer to note number 3. A lot of times what they'll do is they'll just say, hey, right here, bud, go to note 3 and they'll tell you what I want here. That's pretty much all it is. The blueprints are nothing more than a roadmap. That's all. Just a roadmap with directions. Make a right, turn left, that kind of stuff. That's all it is. Nothing overly difficult, okay? Really isn't. That bottom one, see this a lot, especially for us. We'll see it in like a big shower room or bathrooms and that kind of thing, where you need to see the interior elevations of all the walls. So you'll get something like this or like this. So this one is going to be 1, 2, 3, 4, and we'll just do A4 again. They put A5 on there, but so from the center of the room, go to page A4, and you will see detail 1, detail 2, detail 3, and detail 4. Different interior elevations or side views of what you need to look at. You'll also see it this way with a circle, and it'll be the same thing. Same thing. Different variances, different ways of doing it, but all the same meaning, the same purpose. I believe the last one I gave you is just different types of material symbols for different types of product, like concrete, ground, grass, different wall, gypsum board. It's all in here. That's it for the symbols. I bought a GoPro, so I'm working on trying to figure out how that's going to work. But then I'll be able to start doing some more stuff with it, hopefully. Okay, hopefully. I'm working on trying to get this to work right. Also, after next week, there will be a chance for you to take the code class again if you want. Some of you may not have even finished the code class or just want to take a refresher of it. It's going to be completely online. It's 3 nights a week, 4 hours each night. So the lectures and the videos that I'll be giving you will be 4 hours long. 3.5, because you got to implement the break in there, with a 4-hour class. So it's all code. That's all it is. And you can look at the videos over and over and over again. You can do whatever you want. Fast forward through the sections that you already know. The key and the point is that it's all code and it's all refresher and it's detail. I go through the entire code book and I talk about every code section and I explain every code section. So I strongly recommend that you guys do it. Even if you've already taken it once before, go ahead and take it again. The code book that you can use is the one that you may already have. And if you don't have it, IAPMO, and I sent you guys the link. I know I did. IAPMO is allowing you to download the PDF free at this, because of what we're going through. So take a look at that. And again, if you haven't done it already, subscribe to the YouTube channel here, and you'll get all the videos that I have. Look at the Plumbing 1 ones. I just did one for soldering. So I did an example on how to solder properly for the Plumbing 1 students. Go ahead and take a look at it. Make comments. Let me know what you think. Let me know what I can do to make this stuff better for you guys. Okay? And I guess that's about it until I see you next week, huh?